Thank you, Scotty. And my talk today is going to be very much a continuation of the themes that Cameron has so eloquently and comprehensively talked about. So what I want to do is to give you guys an idea about what artificial light is, how it's different to natural sunlight, and how these environments that we've created, these sunlight infrared deficient indoor environments, how they might be contributing to one of the most important diseases in society today, which is metabolic disease and type 2 diabetes. So a little bit about me as the kind introduction, that's all you, more of the same. And some disclosures: I don't have any funding by any company or organization, and there's nothing else relevant from that point of view. I want to start with a quote, and this is from quite a esteemed circadian researcher named Dr. Martin Moreed. And in this paper, he makes the point that for the first 10,000 generations of Homo sapiens, the contrast between bright daylight between 10,000 and 100,000 lux and nocturnal darkness robustly entrained the human circadian timing system to the Earth's 24-hour rotation. However, for less than 4 generations over the past century, this natural 24-hour cycle of daylight and darkness has been replaced in the developed world by electric light. Approximately 90% of our time is now spent indoors under electric light that is typically 100 times dimmer during the day than natural daylight and 1,000 times brighter after dusk than even the brightest moonlight. And this is the study, and it was done in 2001, and it surveyed around almost 10,000 Americans. And what they found was that the time that these people and these average people were spending in their daily activities amounted to 87% of their time indoors and an additional 6% in a vehicle. So close to 90% of their day was in a light environment that is unnatural, that is filtered light. And this is going to be very relevant for the whole talk. So what was the ancestral human existence? Again, it was very bright daylight throughout the day and a nighttime sky predominantly dominated by moonlight, which was reflected from the sun. Where do we live today? We live in these chambers under compact fluorescent light lamps, under cool white LEDs. And at nighttime, we've illuminated our environment. So the question that I want to really examine in this talk is the implication of artificial light for obesity and diabetes. And I hope by the end that you'll take away some points that the light environment is critically important to your risk of developing type 2 diabetes, for depositing dangerous visceral fat, and for generally suffering the chronic health issues that are attendant and go along with metabolic syndrome and metabolic dysfunction. So let's start again with an overview of natural sunlight. And this image is measuring the spectral emission of the sun with a spectrometer close to sunset. And it, as you can see, it has some very, very unique characteristics down on the screen here. It is giving us a broad emission of both visible and non-visible light. It is a thermal light source, meaning that it is emitting so much energy that we can perceive that as heat, standing all that distance away on planet Earth. And quite importantly, it has a constant light output. There is no flickering of natural sunlight. And that's going to be in stark contrast to the lights, thankfully, that we're sitting under today that we've turned off. Here's another pictorial depiction of what is happening throughout the solar day. And what you can see is that there's variation in the wavelength and color temperature as the sun rises and sets throughout the sky. And in the mornings and in the late afternoons, it's dominated by visible light, but also by longer wavelength infrared and red lights. And then as the angle of the sun climbs in the sky, the ability of the atmosphere to absorb the shorter wavelength photons is less, and they get through first as UVA or ultraviolet A light, and then when the sun is beyond a certain angle to the Earth, then we're getting the most high energy UVB light. The key point that I really want everyone to remember is that blue light is always paired and balanced with red and infrared light in nature. Here's another way of thinking about or essentially depicting natural sunlight. And we've got the wavelength on the bottom, and we've got essentially the amount of energy on this axis here. As you can see, UV, the much maligned ultraviolet light, is only making up a very small part of the solar spectrum. But here, in this massive area, is non-visible infrared light. And this is a critical light nutrient that we're going to talk a lot about in this talk. So while most of the solar power is in the visible spectrum, by percentage of photons, the greatest are in this non-visible infrared area. So why is this important? It's because solar radiation, not artificial light, were the optical conditions of existence for all life on Earth for the past 3.4 billion years. And no matter what domain of life, bacteria, archaea, or eukaryotes, all of these, plants and animals, we all evolved with natural sunlight, and that cannot be replicated. I want to give you a little history overview of how artificial light was invented and how our relationship has been with light throughout history. Depending on which source you read, it's suggested that humans domesticated fire between 1 million and 780,000 years ago. Prior to that, again, it was simply sunlight during the day and moonlight during the night, with perhaps occasional lightning strikes. In 1879 was the invention of the Edison's incandescent light bulb, and there were a whole bunch of scientists working on this problem. But the innovation of artificial light was swiftly taken up once that technology barrier was breached. In 1893 was a really inflection point, because that's when electrification was really proven on a large scale at the Chicago World Fair. 1939, the first fluorescent bulb was displayed in New York at the World Fair. And then fast forward to 1996, the first white LED light bulb went on sale. 2007, somewhat of an inauspicious time, and that was both the Nobel Prize in Physics for the invention of the LED light bulb, but also the passage of a legislation in the US that essentially is beginning to act as an effective ban on incandescent bulbs. And I'm going to explain why that is such a problem. So, an incandescent light bulb, these emit both visible and non-visible light. And you can see by these spectral graphs that there's this balance here. And although they only end at or just go beyond what we can see, if you extended this graph, you would see a nice big emission of infrared. The halogen is a form of incandescent bulb that has made some changes to increase its lifespan, and they are similarly emitting this non-visible light and therefore termed inefficient. But what the problem with that depiction of inefficiency is, it really misses the point that this infrared light is a critical light nutrient. The other way of term is called thermal light, and that is obvious because it emits heat. So what if we contrast this with a non-thermal, or this light that was invented more recently? These are the emission spectrum of a cool white LED. Look at that massive peak of blue and a lot of green, and there's almost no red and infrared. Similarly, the fluorescent bulb, the compact fluorescent bulb, is even more of an alien spectrum with almost unrecognizable characteristics, light characteristics, compared to natural sunlight. The other problem with this type of lighting is that there's flicker, and that is just a fact of how the technology is designed, is that it is rapidly turning on and off and on and off. And that has significant consequences for our health, especially with conditions like migraine. And this is also called visible only light for obvious reasons. So I think if there's one diagram for you to take away from this presentation, it will be this one. And that shows you so clearly how different our light needs are today, are historically, compared to what we are existing under in today's day and age. So let's frame this problem. The modern indoor lighting problem. Most people are spending 90% of their time in these hermetically sealed chambers, exposed to less than 10% of the natural solar spectrum that their body needs to run physiological processes and operate optimally. I thought this was a very telling and interesting study, and this is self-reported use of melatonin supplements in US adults from 1999 to 2017. And melatonin, it's obviously being used by people who are self-medicating to assist in insomnia or poor quality sleep. What happened in 2007? That was the effective banning of this infrared lighting. Thermal lighting that contained some degree of infrared. And you can see quite prominently how this use of this essential supplement medication is increasing. So the question is, how does light interact with our bodies? And this is a very, very complex topic that I'm going to touch on in brief. But importantly to know is that the light interacts with our eyes and our skin, and it does so in analogous but also quite unique ways. This image here shows how the different wavelengths of light that we've discussed influence the depth to which the light is penetrating. And the shorter wavelength, higher energy light is more superficially absorbed, and the visible light penetrates even deeper the longer you go. And as was mentioned previously, near-infrared, through its ability to scatter, can penetrate quite deeply, several inches or up to 10 centimeters at least. The critical thing to understand, and I think this is a paradigm-shifting moment for anyone in conventional medicine or in any form of alternative or complementary therapy, is that each wavelength of natural sunlight is in itself can be thought of a nutrient or a medicine. And that means that you can't exclude one of them and expect to be meeting these basic light needs that we've developed over these billions of years of evolution. There's some overall categories of ways of thinking about these light nutrients. There's UV light, vitamin D production, pro-opiomelanocortin stimulation, nitric oxide stimulation, that's all occurring with this shorter wavelength UV light. Circadian signaling is something that's happening with this more of the visible, particularly blue, green, and a little bit of UVA light. And then the longer wavelength, red and infrared, is really what is happening with it's causing water interactions and stimulating mitochondria. I'm not going to talk about the UV light because I really want to focus on the circadian side of things and the red and near infrared. And that is because the domain of UV light, it's sunlight, and that is what we've heard so eloquently from Cameron so far. But the spanner in the works that this lighting, these artificial lights are having, are predominantly in the form of a toxicity an excess and toxicity of visible blue wavelength light, and a deficiency of red and infrared. So circadian biology, this is a process that underlies so much of what is going on in your body. And how it works, and it's quite complicated, but it is incredibly important to understand, is that the light wavelengths, predominantly blue, are received by the eye. And these signals enter the eye and are essentially passed along a neuronal superhighway, an incredibly fast neuronal connection between the retina and the hypothalamus of incredible speed, and where that light informs the programming of a clock. And it's not just any clock, it's your master clock. It's your Big Ben, and it is running and having hierarchy. It is orchestrating the clock timing of all the other clocks in your body. And that is why the light signals are the most impactful in terms of programming your circadian rhythms. And not to say that light signals on the skin aren't important, they are, but in terms of the hierarchy of importance, the light through the eye is key. And when we think about what is happening today with rampant device usage, people on screens, 10 centimeters from their eye till 11 p.m. every night, and you understand how critical that ocular information is to orchestrate all these endocrine and hormonal programs, then you really start to understand what kind of damage is being done to kids, to adolescents, to everyone. One of the key pathways that this light signal, the circadian blue light signal, is regulating is that of melatonin production from the pineal gland. We mentioned it briefly before, but melatonin will put you to sleep. It helps you maintain the depth of sleep. It kicks off repair mechanisms in your cells and helps do cellular garbage cleaning. The pineal gland, when you get that blue light, it stops making melatonin. That's a natural thing that should happen when you go out and see the sunrise and you get that blue wavelength light. That is normal and healthy. But what is not normal and healthy is exposing yourself to artificial light at night and turning off melatonin when it's supposed to be helping you fall asleep. Melatonin is not only made in the pineal gland, and we're going to talk about that, but this is the circadian circuit that is very, very important and really underappreciated by medicine and by mainstream treatment. The last point I'll make is that there's a special light detecting protein, and that's called melanopsin, that is particularly responsive to blue wavelength light. And it ties back to this little critter, the African claw frog. And you might be thinking, what on earth does this have to do with light reception? Well, it turned out that the African claw frog was the first animal that we discovered the presence of this melanopsin blue light detecting protein. And this frog has this melanopsin protein in these what are called melanophores, or little cellular compartments that help it change its color based on the ambient light in the environment. So it is sensing light, it's sensing daylight through these blue light detectors and helping it adapt its skin color to anticipate changes, to avoid predators and the rest. The other point is that melanopsin, like I mentioned, a blue light detector, it's not the only one. Neuropsin and enkephalopsin, and there are whole families of other of these opsin proteins that biology has evolved in different species at different times to help sense different light wavelengths and therefore help the organism essentially survive. The interesting thing is that melanopsin is present in us. We have an ancestral relative in our eyes, in our retina, as I mentioned, in our retina, and in our skin of melanopsin. But not only in our skin, but also in our blood vessels, in our fat cells, and in deeper brain regions. And what it's doing is it's taking in environmental information. It's taking in light information from our environment and and as well as temperature information, and feeding that in to the circadian machinery so your body knows exactly what time of day it is, what season it is, and it's using that information for a range of critical functions. So we are walking blue light detectors. What do you think the implications are of putting blue light above us 18 hours a day if you're a walking blue light detector? Sounds a bit to me like a spanner in the works. So how do we think about circadian biology? This is one way of thinking about it. I don't know if anyone's seen The Wolf of Wall Street. It's a very busy office. They're calling people constantly the whole working day. What is happening in the office during working hours is not the same as what needs to happen after hours. After hours, the place needs to be cleaned, the toilet rolls need changing, the carpets need vacuuming. What would happen if the cleaners came onto the floor at 11 a.m. when these guys are trying to scam people with cheap stocks? It would be chaos. It would be complete chaos. Circadian biology is cellular timekeeping to coordinate opposing physiological processes in the body. That's not the only, but that's one critical way of thinking about it. So you don't eat, the time you're sleeping, you're not eating. And there's a reason for that, because they're opposing, and you don't want to be doing it at the same time. And it's not efficient for the organism to be able to do them at the same time. How else can we think about circadian biology? I like this, and it's a yin and yang, the Taoist symbol, with a clock overlaid. The yin and yang signifies duality and symmetry. Just as bright daylight is critical, so do you need a complete absence of light, or simply moonlight. You can't have one without the other. You need both. And it's not good enough to be outside, but to be illuminated with devices at night. And so it's suboptimal to be sleeping when the sun goes down, but to not get enough sunlight during the day. Why is the clock important? Because the clock is telling the time and feeding that information in. The other point is that this clock and your circadian clocks are not quite 24 hours. And they're not quite 24 hours because they require that constant updating and synchronization from the environment via those melanopsin and other opsin light sensors. And why do you think this might be the case? Well, think about what happens over a season. Is the day length the same? No, the day length is changing. So the organism and your body needs to change its internal timing to match the timing that's occurring in the environment. So it's cellular timekeeping to synchronize to environmental light signals. Now, this is a technical slide, but I think it's important to briefly touch on, which is the clock mechanism that I've described involves a very complex and intricate but very elegant way of conducting timing. And that's when these clock proteins, they go into the nucleus and they make some other types of circadian operating proteins that then go back into the nucleus and act as a negative feedback to stop their own production. This is how this negative feedback loop, it's called a transcription translation feedback loop, is how the body tells time. It's incredibly elegant and it's conserved, meaning it's happening in every cell of your body, and almost every organisms have a similar mechanism. How does this relate to diabetes and metabolic health? Well, it turns out that there's clock timing mechanisms in every single one of your most metabolically active tissues. So clock timing and circadian timing is regulating your master clock that's influencing your whole body insulin sensitivity, your food intake and your energy expenditure through those pathways into the hypothalamus. It's regulating your gut clock, and you can think about how important that would be so that your body's ready to absorb food at the right times. It's influencing your pancreas, and it's influencing the secretion of insulin and the timing of when that insulin is going to be sensitive and received appropriately. So the key points is that we are set up to be metabolically healthy if we're getting light signals at the right time of day. When there's chaos through artificial light, then we have chaos through our metabolic health. This study was a very elegant study, but it essentially exposed two groups, one to bright light and one to dim light. And it was only for a single night, and these were in healthy participants. These weren't in people with pre-existing diabetes. And what they found was that the serum blood glucose levels and the serum insulin levels were significantly associated. The bright light was associated with a significant increase in both of these plasma glucose and insulin, suggestive of glucose intolerance. And you can see how effective the bright light was, because it knocked their melatonin down, as we mentioned earlier. So this all occurred with no food. There was no food ingested. This is an elegant explanation or proof of concept that we don't need to eat the donut. We don't need to eat the Krispy Kreme or drink the can of Coke to raise our blood glucose and raise our blood insulin. It's simple. It's sufficient to be under artificial light to do that for us. Excess blue light causes diabetes, and this review, the metabolic implications of exposure to light at night, lessons from animal and human studies. It shows that artificial light and circadian disruption alters the expression of clock genes in the brain. It alters clock and metabolic genes in the liver. It contributes to lipid accumulation. Has anyone been told they have fatty liver? There's a circadian reason for that. It reduces glucose sensitivity and insulin secretion, and it dampens these amplitude of these key oscillating proteins. What about in large populations? This observational study showed that the prevalence of obesity, diabetes, and hypertension was significantly higher in older adults with light at night compared to those with no light at night, after adjusting for a priori covariates of age, race, sex, and season, as well as measures of sleep and activity. That basically means if your grandma sleeps in her bedroom with a light on, with light pollution in her bedroom, depriving herself of complete darkness that we've explained is necessary, then she's at risk. She's at risk of developing insulin resistance, of putting down fat around her abdomen, getting insulin resistant, hypertensive, and eventually diabetic. How's another way of thinking about what's happening? Circadian misalignment, when we're exposed to light at night, or if we are intaking food too late, if we're eating at 10 p.m., 11 p.m. at night, we are desynchronizing those peripheral clocks that I talked about in the gut and in the liver and the pancreas from the central clock in our brain that is being received through our eyes. And that desynchronization, that circadian misalignment is driving in large part these disturbances in our metabolic health. I could go on. Circadian rhythms disrupted by light at night and mistimed food intake alter hormonal rhythms and metabolism. Chronic circadian shift leads to adipose tissue inflammation and fibrosis in a mouse study. And these mice were essentially replicated on shift work. They were given a shift work schedule, and they were given the same food as the other mice. But after 6 months, they had fibrotic fat, they had more subcutaneous and visceral fat, and they were insulin resistant. No change in the food. Circadian dysfunction induces leptin resistance in mice. The pathways are consistent and well demarked to connect artificial light at night to metabolic disease. Let's talk about red and infrared and how that is relevant. And like I mentioned, it's a critical nutrient that we are now becoming deficient in. This study is possibly the most elegant and simple illustration of the effect of red light on blood glucose. And all that happened was a group of people and a group of controls. One got 15 minutes of 6-7 nanometer red light on their back prior to a glucose challenge. And people might have drunk the 75 grams of glucose through their doctor. Through Dr. Rob might have written a script for that, or not anymore. And what they found was that the pre-treatment compared to placebo was the blood glucose in those who received the red light was significantly lower. And that's an incredible finding. It was up to 27%, because these people they had the same amount of glucose. They had everything else was kept the same. It was a randomized controlled trial. The important point to note was that in this group, they measured an increase of carbon dioxide coming out of the mouth and the nose of these people, meaning that the red light was revving the mitochondrial engines up. The exhaust of your mitochondria is carbon dioxide. So the red light was essentially turning up the engine and essentially burning more glucose. It was sucking the glucose out of the system. Melatonin and the optics of the human body, possibly one of the most landmark, most important papers of the past 5 years, longer, that I don't believe has received anywhere near amount of the reception that it requires. What Scott Zimmerman, who's not even he's actually an optics engineer, he's not medically trained at all. What he did was optic modeling of the absorption and scatter of light of the human body. And what he found was that this near infrared light, this light was penetrating deeply into the body, and it has a critical role in generating melatonin, but not in the pineal gland, in the mitochondria. And the critical difference is that melatonin is not only having a sleep effect, but it's having an antioxidant effect. And just like people take vitamin C, they take the latest superfood to get an antioxidant effect. Well, it turns out that your body over more than 3 billion years, because melatonin is found in single cellular prokaryotic life, it's innovated the most efficient antioxidant basically known to biology, and that's melatonin. So melatonin is being generated inside your mitochondria on exposure to near infrared light. And that is why it is such a profound light nutrient, because melatonin is how you defend against cancer. Melatonin is how you defend against oxidative stress. And this is critical. What do they say? They said that near-infrared photons are scattered several inches into the body, even through the skull. And Cameron mentioned the exact same finding. Due to the low optical absorption and an isotropic effect, the scatter of the scatter in the human body at this wavelength range. So what's it doing? This near-infrared light from the sun is penetrating through our body. It's getting into cells. It's getting into these mitochondria, these little organelles, these power plants of our cells, and it's helping us make this antioxidant compound melatonin. And it's in terms of the total body production of melatonin, this melatonin actually dwarfs the amount that gets made by our pineal gland by something like it's an order of magnitude at least, which is again something that is unknown to the circadian researchers and most of science at this point. So humans are optimized to harvest near infrared light. Just like I mentioned, we are designed to sense blue light. We are designed to harvest near infrared photons. And this is the same diagram that was shown previously. And what they say is that the cerebrospinal fluid, the liquid around your brain and your spinal cord, optically acts as a light guide, distributing the near-infrared photons, scattering off the surface of the brain, even into the deep folds of the brain. And they needed an optics engineer to find this out. No one in medicine had the skill set, the intellectual paradigm to even ask this question. But Scott Zimmerman, who is approaching this problem from a completely different perspective, did these measurements and noticed strikingly the optical characteristics of our body was similar to that he saw in aerospace, that he saw in automotive industries that are using different configurations and designs to essentially reflect light. And it turned out that Mother Nature has done the same thing. So what that means is that this infrared must be so critical that your body has given you an ability and it wants all this near infrared to enter, and then as Cameron mentioned, ping pong around. The near infrared photons aren't absorbed like blue is by that melanopsin type protein. It's not absorbed easily like UV light is to cholesterol. It ping-pongs around, and in the process of ping-ponging around, eventually penetrates deeply and then is having this effect to stimulate melatonin production in the mitochondria. It's also structuring the water inside your body, but that's a talk for another time. What else? And I think this is relevant for Mel and anyone who's in obstetrics and women's health, because it turns out that it's not only the cerebrospinal fluid that is concentrating this near infrared light. The fetus is surrounded by the amniotic fluid, which has a peak transmission in the near infrared, forming a dielectrically filled integrating sphere surrounding the fetus, ensuring uniform exposure to the near infrared photons impinging on the mother's belly. I mean, how profound is that? That means that the Mother Nature has designed a system that values near infrared light, the light that they've taken away from you with this artificial light here. It values it so much that it is essentially encasing your baby in a fluid that means that it can harvest as much of that light and as many of those photons as possible. Yet we're being told to avoid the sun. What are the implications? It's so profound that we're only scratching the surface of what this means. And it also speaks very strongly of the requirement for women to get outside and get some sunlight, not necessarily with exposed, but there's other benefits, but simply be outside in natural sunlight. What is another way of thinking about how these effects? Well, red and near infrared light are directly being absorbed by these cytochromes on the electron transport chain in the mitochondria. These are like the pistons of the engine. These are the pistons of the power plant, the battery of your body and your cells, and they're directly receiving this light. So what is it? It's like a mitochondrial lubricant, because it's helping the head of this fifth complex spin better. So without red and near infrared light, if you live indoors in a cave, you're depriving your energy making apparatus in all your cells of the lubrication it needs to operate optimally. I mean, we've got a lot of farmers in the audience. What happens if you don't change the oil in your tractor for years on end? It's going to seize up. Your engine's going to wear out and seize up. Well, the same thing is happening with you if you avoid the sun. And what else? The subcellular melatonin that we talked about was being generated. That is acting like a coolant, because this process of energy generation is developing reactive oxygen species. And those reactive oxygen species damage mitochondrial DNA. And when the mitochondrial DNA damage occurs, the cell stops being able to produce energy properly. And all of chronic disease, 95%, depending on who you talk to, Dr. Doug Wallace of the Children's Hospital of Philadelphia, of chronic disease is a bioenergetic failure. You get diabetes, you get neurodegenerative disease, you get cancer when your cells stop making energy properly, when your mitochondria stop making energy efficiently and your cells have a brownout. The cellular brownout, if that continues over decades, manifests as cancer, it manifests as diabetes. It just depends which organ that problem manifests in. And that's also related to genetic predispositions and a range of other things. So red and infrared light, this forgotten part of the spectrum, is fundamental to improving mitochondrial function. How do we know this is another way we know this is effective and efficient? Well, there's a whole scientific field of photobiomodulation that relies on the therapeutic use of red and near infrared light. So people who are saying, red light is quackery, you can just jump onto PubMed and find the therapeutic effects that the clinicians and scientists are getting by applying these light wavelengths to amazing range of diseases, from improving symptoms in Alzheimer's disease, improving muscle recovery in musculoskeletal injury and athletic performance. So it's fundamental. This is photobiology. This isn't quackery. It is fundamental photobiology. So there's a twofold problem here that I hope you are appreciating as we've got this far. The first is blue light toxicity. It's an excess of artificial light at night, and it's causing circadian disruption, and it's causing a disruption of our circadian cycles. And the second is an absence of full spectrum sunlight, including near infrared and red, from indoor living. Insufficient sun exposure has become a real public health problem. So this is another way of looking at the same problem. And we already know that a lack of sunlight leads to poor health. Those with lower vitamin D levels live less and suffer an increased incidence of almost all chronic diseases. Well, why do you now know why that might be the case? Is because when you get insufficient sun exposure, you're getting a lack of both UV light, which is showing up as vitamin D deficiency, but also UVA and near infrared and all those non-vitamin D related pathways that Cameron mentioned earlier that are critical for health. So how do you create diabetic lighting? I'll give you a recipe. You disrupt circadian rhythms with blue artificial light at night. You provide an environment where blue light is present without red and infrared. And you deprive yourself of 90% of the natural solar spectrum, and you do that every day for 20 years. Well, it just turns out that is what is the reality today. And that is the reality that's actually been created and facilitated by your government, by government regulation, by government intervention in our right to choose human appropriate lighting. This is a provocative point that I'm going to leave here, and it's very rhetorical. In the past 140 years and since the development of the electric grid, do you think that there's been a comparatively radical shift in the composition of the human food diet versus these light changes that I've just discussed? And this is a meat, potatoes, and veg dish that probably could be from 250 years ago, and it's a burger and fries. Something for you to think about. So let's talk solutions. What do we do about this? We need brighter days and darker nights. Very simple. Be outside during the day, and when the sun's gone down, turn your lights off. And I don't think I've heard as elegant a circadian appropriate routine in a long time as yesterday, Cindy's routine. And I think that is a model of to copy and to aspire to. And that is appropriate, circadianly aligned routine that will ensure that you are respecting your circadian rhythm, that you are giving your body these critical light signals, and that you are essentially creating molecular order, allowing those cells to do what they need to. You need more time outside. And we can't see infrared, but specialized camera technologies can. And the ground, the leaves, the chlorophyll-rich leaves are reflecting this light for us. And maybe if you want to take a theological bent, you might think that, yeah, the plants are providing this for us. They're reflecting it for us to use. Whatever your perspective is, you need to be out there, because that is how you can get it. And yes, you can get it through clothing. And that is courtesy of Professor Robert Fosbury, who's an astrophysicist, like Scott Zimmerman, who's approaching light and biology from this radically unique perspective and really having profound breakthroughs in our collective understanding and education about these topics. What else? You need more daytime sunlight. You ideally would be sampling a little bit of this light information at every part of the solar day. If you're pale skinned in Australia, there's a mismatch there. You don't have as much melanin in your skin compared to the Indigenous people, compared to the Indigenous Australians. That's okay. You just need to be careful with a high intensity UVB. You can still be out. You can be completely naked early in the day and night, because there's not a large UV yield to do a lot of damage. You just have to use the shade. The opposite problem is actually much worse, which is if you are darker skinned and you're living in Tasmania, If you're from the equator and you're living in Tasmania, that's a mismatch that is much more difficult to reconcile. And the first advice that I would always have for someone like that is you need to move. It's harsh, but it's who's seen a coconut? Who would plant a coconut grove in Norway? It sounds ridiculous, doesn't it? Imagine trying to grow coconuts in Norway. Our photobiology is different, but is not so different from plants that analogy is somewhat applicable. And that is why people with darker skin types do so poorly in psychiatric illness, in metabolic health, infectious disease, COVID susceptibility, if they're living at a latitude that is so far north and different to the ambient light conditions that they evolved with. The light should be unfiltered because there was no sunglasses, there was no sunscreen, there was no contact lenses in our ancestral past. And that filtration, it changes the way the light messages are sent and received. You can even build your solar callus, and that is, again, to harness health benefits, including the ultraviolet light. So you want to minimize light at night. Again, ideally there's none. Ideally it's darkness, but we all have lives, we all have work, we all have things that we have to do. So one option is candlelight. One option is an LED, but it's a red LED. And if you put these closer to the ground, at ground level, your interference with that pineal gland's melatonin secretion is less. Again, it's not ideal. These are mitigation steps, but it is preferable to going home, flicking on the LED downlights and, blasting yourself at 10 p.m., 9 p.m. with, a daylight signal. You can block blue light. And remember, the eye has the most concentrated density of those melanopsin blue light sensing proteins. So if you have to, this again, it's mitigation, then wearing a pair of blue blocking glasses, it will definitely help. Put infrared light back into your environment. And incandescent bulbs, they're now contraband. I don't know, maybe someone will start running light bulbs in a smuggling operation. You guys will be the first to hear about it. But these are banned now. And they're banned because they are inefficient, in inverted commas. But now, they're not truly inefficient. They're giving you an amount of this red and infrared that you truly need to thrive. And yes, it'd be better if you were outside and you had your office outside and all the rest, but this is the next best. Again, Professor Robert Fosbury, he's made this really elegant workaround, and what he's done is he's got a really small incandescent bulb running at a very low voltage, and that gives us that nice big red and infrared area, and he's paired it with a visible only LED. So what it's allowed him to do is generate a more human-friendly light environment, it's actually quite easy for everyone to do. And you can see that if you take a photo with that near-infrared camera, then it's emitting some. And really, we need to start advocating against this visible-only lighting because it is optimization in the wrong direction. It's a misguided attempt at improving human health, but it's so myopic that it doesn't realize that it's really the law of unintended consequences is doing a lot more harm than good. And these decisions are being made by bureaucrats, by people who have no understanding of the data that I presented to you and the effect of light on health. So in summary, humans are walking blue light detectors and near-infrared light collectors. Modern artificial light, indoor lifestyles, and sun avoidance are driving obesity, diabetes, and metabolic disease. In part, not the only mechanisms, but in part via circadian disruption, near-infrared deficiency, and mitochondrial inefficiency. Collectively, we need to shift attention away from pharmaceutical, supplements, and diet-only therapies, and to understand the critical importance of light. We need to increase outdoor time and sunlight. We need to reintroduce human-appropriate lighting and consider the use of things like photobiomodulation where appropriate. And consider based on everything that I've said, that your health issue might not be first and foremost a light problem. And that speaks to the centrality of light and circadian health to what is happening in your body and in biology. If you want to learn more, I've got a couple of courses that deal with the yin and the yang that I mentioned. Circadian reset for avoiding light at night, and solar callus for safely getting and harvesting UV and daytime light. Thank you for listening.